Okay, we are doing graph theory. In the first session, uh, we will we have this Königsberg bridge problem. We see the proof given by Euler. We also see the result of the graph theory. We are doing graph theory. In the first session, uh, we will we have the next the last class we have seen the how graph theory helps in scheduling the tournaments, the sports tournaments. Now today I want to show you some aspects of social networks where graph theory um, plays its role. So nowadays mm, we are we all are on different social networks like Twitter, Instagram, Facebook, etc., etc. And I think you people are also are on the social networks. So can you uh, can you tell me your experience on the social networks, how you use the social network, how it affects, and how do you think mathematics can how mathematics can be playing a role in the social networks as well? Anybody? Brian?
On social media, there's often a recommendation algorithm. So if you watch something and then like it, you'll get similar videos, which is um, based on what other people have watched as well.
Okay. So I'm more here. I'm asking about social network, not social media. Social media is a little different thing. So, so social networks like Facebook, and these are as well as a media as well, but they are network as well. So, like for example, if you are on Facebook, so let's see, for example, the people on the Facebook can be modeled as the vertices of the graph, and 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 the relationship, some kind of social relationship between the people can be modeled as the edges, like friends. For example, if I say like friends of, so friends of is an, you can consider as the edge between the vertices which shows the people. So I take vertices as the people, and edges represent some kind of the relationship between them. That can be relation of the type like friends of, married of, like in on Facebook we have friends. So the people are vertices, and there is some edge between two vertex if these two uh, people are friends with each other. Okay, so um, graph. So you can represent any social network by a graph, and we can call that graph a social graph. Okay. Can you tell me any other example from this network, um, in which we can, let's suppose we are taking vertices as people, and what type of relationship can be represent as edge other than friends, like
Sir, I think we can take nationality as the edge.
Good, very good. Of the same nationality, the people of the same nationality,
Yeah,
they can share edge between each other. Good, very good. Or
the same community.
yes, same
If
community. So if two-person belongs to the same community, they share an edge between each other. Similarly, for example, if two people goes to the same school, they can share an edge between them. So a lot of relationships can be modeled through the edges. It means that all these we can analyze all these type of relationships by the graphs, by analyzing the graphs. Okay, so today I'll more uh, take an example of Facebook, and I ask you, what do you think how Facebook is working? Mean, uh, like I have, whenever I open a Facebook, I have a news feed every day, but that news feed is made by Facebook. Okay, so what do you think how Facebook generates that news feed for me or for any person? So what do you think the Facebook is doing? Because Facebook, the people on the Facebook, you can say again, if you are taking them as a graph, they have all these informations of these relationships. The some persons are of the same nationality, some persons of the same community, some persons goes to the same school, so they have all type of data present in the Facebook. So my question is now, so whenever I open up my Facebook page, um, I log into Facebook, so there is a news feed page. So how the Facebook manage the news feed page for me? What do you think?
They look at what your friends or people in your community are looking at,
Hmm. Yeah,
or your past searches.
good.
so they may give you popular news, what's trending, or what's breaking news on the headlines in your own country, in your own community, or some it can give you international news, and it can be in different categories like about economy, travel, or tourism. But if it's a certain person, then it depends on what he looked at before or what he looks at most of it. Like if I am interested in news really relating to the economy of a country, of for example of my own country, and I look at that news all the time related to my country, then the next time I open the Facebook, it will always give me news relating to the economy.
Good. Okay. Next question is that the Facebook have a lot of data about the people and all these, that people are looking which news, and people are making friends with which type of peoples. So can anything useful be can be done with all these things? Question.
Yes, sir. Communication. First thing, it's making communication with people easier. Having similar interests or consultation with them.
Okay. Anybody else? Okay, let's think about, let's think like a marketer. If you are a marketer, then how this Facebook thing help you?
Uh,
Think like,
if you're a marketer, what you want is for people to stay on Facebook longer, so they look at more ads and you get more money from that. So by recommending things that they're likely to be interested in, they'll spend more time on Facebook and then generate more money.
okay, good. Anybody else?
So I agree with what he said.
Other than
So the same
SAR?
can be done.
Okay,
So
okay, sir.
if I have a product and I want I want to generate money, I want to sell that product, I want to have a lot of sales and profit. What I can do is have my own ads on Facebook or reach out to an influential person who has a large following on Facebook, and he can promote my product. So informing other people, communicating my product, promoting my product.
This is very important thing. The thing you're saying about the influential person. So how Facebook knows about the influential person? Next question is that how Facebook comes to know about the influential person? Who is the influential person?
The people
The
with
person,
more followers or friends or likes or views.
Good, very good. So there must be some measurement which measures this thing that which persons are more influential than other. So this is a big question, mm, that how can we come up, mm, can we come up with a good measure of social importance or influence? Or are there multiple measures? And if there are, what are their relative measures, the merits? So my today's topic is about this thing, measurement of this social influence thing using graph theory. Okay, so my main topics, today's main topic is to introduce you some measures of social influence. There are many things which we can be analyzed using the graph theory. So but my today's topic is how uh, graph theory help us to measure the social influence. Okay, so let's start with a very simple thing. As you have mentioned, that maybe a person is more influential if it have more friends and more um, likes and all these stuff. So this thing that influence is measured by connectivity. Mean if people have lot of friends, then it tend to have more influence. So before going to give you any measure, I want to just recall what we have the some notions of graph theory, uh, and also today I'll relate the graph theory with linear algebra as well. I give you some matrices which are associated um, with the graph. So everybody knows about matrices. Is there anybody here who does not know about matrices? Have you ever Um, do you have any course of linear algebra in A levels, or if you are a university student, then have you go through the linear algebra thing? Vector spaces, have you studied vector spaces, or you studied only matrices? Sometimes matrices are used to to solve linear equations as well. Nobody?
You do have some vectors and linear algebra in A levels.
Okay. So can everybody knows about matrices? I'm saying, do you have the idea of matrices? Everybody has the
Yes, sir.
idea of matrices?
Yes, sir.
Okay, very good. So this means that you do not have any problem with the matrices. Okay, so in the last two classes, I have mentioned you that graph G, if I denote it by G, consists of two type of sets, consist of a finite set of points, which we call as vertices, connected by some line segments called edges. Okay, so let's suppose you have a graph. I am associating three matrices with any graph, which are helpful in analyzing the graph, and then using those matrices and those things, I will give you the different social influence, the measure of this different social influence. So first definition is about the incidence graph, incidence matrix. Okay, let's suppose you have a graph G with n vertices and n edges. Let's label the n vertices by v1, v2, up to so on vn, and let label the edges with e1, e2, up to so on en. Okay. So incidence matrix, incidence matrix denoted by denoted by C of G consists of elements Cij, and then the elements are either 1 or 0. We have the entry 1, ijth entry 1, if vi is one of the vertices of ej, and 0 otherwise. Okay, this is called the incidence matrix. Actually, incidence matrix give you the relationship between the vertices and edges. It tell you how the vertices are con connected with edges. So, for example, if I have a graph, let's suppose I call this I take very simple graph. This is V1, V2, V3, V4, E1, E2, E3, E4. So in this graph, we have four vertices and four edges. So the graph will be 4 by 4 matrix. First entry, C11. So V1 is one of the vertex of E1. So this is 1. V1 is not a vertex of E2, so 0. V1 is not a vertex of E3, so 0. V1 is a vertex of E4, so 1. Next, V2. V2 is a vertex of E1, so 1. V2 is a vertex of E2, so 1. V2 is not a vertex of E3, so 0. V2 is not a vertex of V4, so it is 0. Okay. Next, V3 is not a vertex of V1, so 0. V3 is a vertex of E2, so 1. V3 is a vertex of E3, so 1. V3 is not a vertex of E4, 0. V4 is not a vertex of V1. V4 is not a vertex of E2. V4 is a vertex of V3, and V4 is a vertex of E4. So this is the matrix associated with the graph, which we called as incidence matrix. This matrix gives you the relationship between the vertices and edges. Okay, is it clear?
Yes.
Very easy. Next, very important matrix is the adjacency matrix. So adjacency matrix is a square matrix, and by n square matrix denoted by A of G, and its elements are defined as Aij are the elements here are also 1 and 0. They are 1 if Vi and Vj is the edge of the graph. It is 0 otherwise. So this matrix actually gives you uh, the the relationship between the vertices. So in other words, you can say that this in from this definition, you can say that two vertices are we can say two vertices are adjacent if they share an edge. Okay, so like in this example, the adjacency matrix A of G is equals to now somebody from you tell me the first row, Hamna. Hamna, can you tell me the first row of this matrix? If you understand this definition, you can. If not, please tell me. I'll repeat the definition. What will be the first row of this matrix? Again, this matrix is a 4 by 4 matrix. So this is the graph, and I'm asking the first row of the adjacency matrix. Hamna, are you there? Are you thinking about it? There are two Hamna. Hamna Bilal. Okay, Hamna Bilal. Okay, anybody else? Rahim Ali.
I think it would be 1, 1, 1, 1.
So he's saying 1, 1, 1, 1. So why this is 1, 1? The first one. Why first one is 1?
Because V1 and V2 are connected.
This is the first entry. This is A11. This is A11.
Oh, then
A11 means that V1 Is V1 belongs to the edge? So the answer is no.
No.
So here it is 0. Okay, Ryan?
Yes.
Understand? Okay, next V1, V2. So V1, V2 is connected with the edge E1. So yes, it is 1. Next is V1, V3. So
No.
V1, V3 is not connected by an edge. They do not share some edge. So this entry is also 0. V1, V4. Now V1, V4 share this edge E4. So yes, this is 1. So the first row is 0, 1, 0, 1. Okay, who tells me the second row?
How did you call my name?
Yes, yes, Hamna, I'm asking you, can you tell me okay, at that time I'm asking the first row, now I'm asking, can you tell me the second row?
Okay.
If you were there and you
As the
understand the
matrix, the row of the matrix.
yes, so I'm asking the second row of this matrix. The matrix is defined like this. This is the definition. The entries are 1 if the Vi, Vj, so Vi, Vj shares an edge, otherwise 0. So we write the first row. Now tell us the second row.
For AIG, for AIJ.
Yes. So I'm asking actually A21, A22, A23, and A24. So what is A21?
A21. It should be. I wasn't there at the moment. I really don't get what's going on at the
Okay.
moment.
Okay, I tell you.
Maybe later I could answer.
Okay. So A21 means that we have to check whether vertex V2 and V1 shares the edge. So V2 and V1 share the edge E1. So we have 1 here. Okay. Okay, next, anybody else tell me what is A22? Husamuddin, can you tell me?
Sir, it must be 0 because V2 and V2 like do not
Yeah,
share any edge.
they do not share any. So here we must have 0. What about A23?
It should be 1, sir, because V2 and V3 share the edge C2.
E2, yes, good. So it is 1. And what about A24?
V2 and V4 do not because they don't have any edge that joins them.
So we have 0 here.
It would be 0.
Good. Okay, next is what about the third row? Third row
I
starting.
think it must be 0, 1, 0, 1. Because V3 is not joined by an edge to V1 and it's joined by an edge to V2, not by V3 and by V4. And I guess the last row must be 1001. No, it must be 1010. Sorry, 1010.
1010. So this is
Logical matrix.
sorry.
Are we forming a logical matrix? One with the Boolean numbers.
No. We are not making the logical matrix. We define this matrix. First, see this definition. Okay.
Sir, the last
we are using this definition. G. In the last, yes,
sir,
in the last it should be 0.
0.
Good. So we are making the matrix, or we define that matrix adjacency matrix, and the elements of, or the entries of this matrix are defined as Aij. So the Aij is 1. So there are only 2 entries, either 1 and 0. So we call it 1 if Vi, Vj belongs to the edge, and 0 otherwise. There is one more version of this matrix. Last time I give you 2 types of matrices, directed graph and undirected graph. So here this is the definition for undirected graph. So when there is a this is a definition for undirected graph. So when the graph is directed graph, so we may have like we have an edge from uh, let's suppose if I have an directed graph, let's suppose I have an edge from V1 to V4, so I have an arrow. So that's if I have an arrow from V1 to V4, then I'll write positive 1. And when we have when I'm writing A41, then I'll write A41 will be -1. So in this case, if the graph is directed, A14 is equals to +1 and A41 is equals to -1. Okay. Yes, A14 is +1 and the A41 is -1.
So I
So
have a
there are
question.
three entries at that time, 1, -1 and 0. Yes. Do you have a question, right?
You know, on the definition for an adjacency matrix,
Yes.
Vi and Vj, is that an ordered pair?
Yes, this is an ordered pair.
Okay. So does that mean this is also directed?
Yes, you are right. Last time I have told you that it is also directed. I need to write here as a set. I usually saw in the books that they do not strictly follow this thing, but I think we must have to follow this thing that for the directed graphs we use the ordered pairs, and for the undirected graphs we have to use the set. Okay, so everybody understand this matrix, adjacency matrix. This matrix actually tell you which vertices are adjacent to each other and what are not. So when we have a 0 there, so A13 is 0, this means that V1 is not adjacent to V3. And what does it means in graph theory that some vertex is adjacent to some other? It means that there is no adjacent to each other means that they have an edge between them. So whenever there is an edge between two vertices, they are adjacent to each other. Okay, one more, not one more, there are two more matrices. So there is another definition of a matrix which we call as the degree matrix. Do you remember the degree? Last time I have told you about the degree matrix. Degree about the degree of the vertex? Can anybody tell me the definition of a degree of a vertex?
The number of edges connected to that vertex.
The number of edges connected by the vertex. Yes. This is the definition for an undirected graph. And for the directed graph, we have two type of degrees, in degrees and out degrees. And the sum of the in degrees and out degrees is the degree of the matrix. Okay. So the degree matrix of G D of G, let's call its elements as Dij, is defined as so Dij will be equals to degree of Vi if I is equals to j and 0 otherwise. So can you tell me the degree matrix of the graph? This is again n by n matrix because there is no role of we are not considering edges, we are also only considering the degree of the vertices. So there are 4 vertices V1. What is the degree of V1? It is 2. The degree of vertex V1 is 2. V2's degree is also 2.
Sir,
V1, yes. Yes. What is the question? Do you have any question?
no, sir. I was saying that every vertex in this is a 2 second degree.
Yeah, you're right. The every vertex has the degree 2 because every vertex is connected by exactly two edges. So the matrix will become 2 0 0 0 0 2 0 0 0 0 2 0 and 0 0 0 2. So these are the this is the degree matrix of the graph. Okay. In the last, there is one more matrix which we call as the um, graph Laplacian or Laplace matrix. This is also very useful in different places, and I represent it with L, and L of G is actually equals to D of G minus A of G. Okay, so degree matrix of a graph minus adjacency matrix of a graph is equals to the Laplace matrix or the graph Laplacian. So these are different types of graphs, different types of matrices associated with the graphs, which helps us in analyzing the graph. They also help us in because whenever in, in different softwares, it is helpful if you can represent a graph with a matrix. So they're also helpful in uh, in softwares, in putting the graphs in softwares, in representing the graphs in different softwares, in different mathematical softwares. Okay, let's come to our thing. We are defining some good measures for the social influence. So the first one is degree centrality, which is based on your observation, in which you are saying that a person with a lot of friends or more friends uh, is tend to have more influence than other. So we define a function, influence function, you can say. I write it like ID. Okay. And if P is a person, IDP is the measure of influence of P. So we have like we are analyzing Facebook things. We have a Facebook or a social graph uh, in which the vertices are persons and in which the edges are the edges tells us the relation between the relation of vertices are people and edges are giving the relation is friend of. Okay, so we are taking this the graph which is representing in which the vertices are representing people and the edges are representing his friend of. Okay, then the IDP, this function is equals to the value of P is equals to the degree of P. So what is degree of P? So degree of P actually tells us the number of friends of the uh, person P on Facebook. Okay. So this is the first measure which we call as degree centrality. What is the advantage of this measure? The advantage of this measure is that it is very simple to calculate, easy to calculate. And if we are talking about as in graph, if we are representing graph as in matrix, if now you tell me, let's suppose if we represent the graph G as adjacency matrix. Let's suppose आपके पास graph नहीं है but you have adjacency matrix. So how can you tell the degree of P or the number of friends of a person on Facebook? I recall you the agency matrix. Agency matrix is the matrix which tell us the edge the relation between vertices. The two edges, do two vertices. If two vertices are connected by some edge, then the corresponding entry is 1, otherwise it is 0. So can you tell me how do you know the degree of the matrix, the degree of the vertex from the adjacency matrix? Or the value of this function IDP? How do you get the value of this function P?
The rows can tell you if there's a 1 in a certain row, it'll tell you what vector points that it connects to.
Mhm.
So if you sum them, you'll see how it's influenced.
Yes, the sum of the elements in a row. Okay. So the sum of the elements in a row, like the first row, if you add all the elements of the first row, that 1, 1, and 1, it is 1 plus 1 is equals to 2. So it gives you the influence of the person which is represented by V1. Okay. Similarly for V2, if you tell this the row sum of this the second row tell you the sum of the second row will tell you the the influence of the second person. So this function can also be represented as that IDP. Let's go IDPI. If I represented PI, then this is equals to the row sum of, sorry, sum of the entries in ith row. Okay, do you understand? The sum of the entries in adjacency matrix in some ith row is the degree of that VI. And the degree of VI tells you the number of friends of a person P. And this is one of the measure of how the person is, how much is the person is influential. Okay, but I'm giving you a scenario in which uh, this measure is not good. Let's see, I have a graph of two persons. First, I will take, I denote the persons by P1, P2, up to so on. So let's suppose if you have a person P1 and it have friendships, let's suppose it have friendships with 8 people. Okay. One, two, three, four, five, six, seven. Let's suppose this person P1 has 8 friends. Okay. And there is another person on the Facebook P2. So P1 have 8 friendships means the degree of the P1 is 8. Now there is another person P2 which has degree 3, but the people who have uh, the other people which are connected to P2 also have 3 friends. Now, what do you think? Which person is more influential or more connected?
Sir, like the person itself being more connected, I guess would be P1, like the direct connections. However, indirect connections, we could say probably person 2, because he has 3 connections and then those 3 people have further 3 connections. So indirectly, I guess P2 has more connections, but directly the person who is like the above diagram, that is P1, that person would have more direct contacts with
So
people.
yes, okay, more direct contacts, but what do you think more influential in this case? Who will be more influential, P1 or P2?
So I think I would go with P1 because like if there's something which P1 starts, then he could directly go to people and tell them that I have started this. But if P2 starts some sort of any drive or something, then he would go to only 3 or 2 people and would say that I have started this, and maybe those 2 or 3 or probably 4 people are not that interested in spreading the word for P2. So that's why I think P1 would have a better chance of, uh, I guess, spreading this word or getting more support.
Okay, anybody else? Anybody else have a different point of view?
I think people connected to P2 can forward a message to the people connected to them. So then P2 would be telling 12 people.
Sorry, Ryan, can you repeat? I do not understand your point.
The people connected to P2 immediately,
Yeah.
they can share it with those people, and those could possibly share with more people. But actually, that's not being shown in the graph, but eventually it's possible everyone on the graph may find out about something P2 is selling or um, starting a project maybe.
Okay, if we are talking that every connection has the same value, then which one is more influential? We do not know about which person is have taking more interest, which are taking less interest. Let's suppose everybody has the same importance. Every vertex has the same importance. Every person has the same importance. Then if for example P1 is giving some message, so it will gives this the reach of this message goes to 8%. But if P2 have some message, gives some message, then the reach of this is goes to 9. It is indirectly, but it goes to 9%. Now the degree thing, if we are analyzing the degree thing, the degree of P1 is 8, and here the degree of P2 is 3, which is less than the degree of P1, but indirectly it has more connectivity. If everybody has the same, if you give every vertex the same value. Do you agree with us now? Do you agree with me, Hasamuddin?
Sir, I got disconnected. Can you please repeat the last part which you said?
I'm saying that in terms that every people in this graph, in both graphs, the vertices are showing the people, okay? And every vertex has the same value, or every person has taking the same interest, then um, P2 is indirectly is more influential than P1, uh,
Yes,
because
sir.
the reach of P2 is more than the reach of P1. But the
Yes, sir.
degree of P1 is greater than the degree of P2 according to
Yes,
our this
exactly.
this measure, the which we have studied now, IDP. The person P1 is more influential, but this case it seems that the other person is P2 is seems to be more influential. So in order to measure this indirect influence as well, there is one more um there is one more what you say the measure in which we use the eigenvalues. So do you have studied about the eigenvalues? Have you know about the eigenvalues? If no, I'll tell you what is an eigenvalues and or what are the eigenvectors.
No, sir, I don't know what's eigenvalues are.
Okay, okay, I'll tell you. So first, I'll tell you we are using the eigenvalues. This term, the eigenvalue is related to the matrix. Since we assign every graph three different types of matrices, which are giving some different types of relationships. So we use here this eigenvalue thing. So first, I'll tell you what is an eigenvalue or an uh, eigenvector as well. Okay, so definition of an eigenvalue or an eigenvector: a square matrix. So let's suppose you have a square matrix A n by n. I also tell you this that every time whenever you have a matrix, this gives you a linear transformation from Rn to Rn. Okay, I have told you what is Rn in my first or second lecture of geometry. So basically, Rn is, if you do not know, if you don't remember, I tell you that Rn is the nth Euclidean space in which the elements are like this. They are ordered n tuple, and each element here is a real number. We can also take these elements as vectors. So we can also take these elements as vectors whose components are x1 to xn. I think you know these things from your A level curriculum. So actually, whenever you have a matrix, it is representing a transformation, a linear transformation. Linear transformation is just a matrix. So it's just a function from Rn to Rn, which satisfies these two things, that A, when applied to vector 2 on the sum of two vectors, then this is equals to A of x plus A of y. So x and y are vectors. Okay, vectors mean they are elements of Rn, and when there is a scalar is multiplied by some vector, so and you are applying this transformation on this, so it will be applied like this. Okay, so whenever you have a linear transformation from Rn to Rn, so this linear transformation can be represented by a matrix. Okay, so we say that an element of Rn, let's suppose I call it V, is an eigenvector of the matrix A, or the linear transformation if there is a real number lambda such that AV is equals to lambda times V. Mean this matrix, whenever you apply the matrix on this vector, you will get lambda times V. So in terms of transformation, you are saying that whenever you are applying this transformation on this vector V, so this gives you a vector which is parallel to the vector V. Lambda V is just, if the direction of that vector is same, just it scales up or down depending upon lambda. So this lambda is called, okay, and this lambda is not non-zero number. This lambda is called eigenvalue. So this concept is very important. This concept is very important geometrically, as well as this concept is used in so many places. Like we are using this concept of eigenvector in the now we are going to see the new function, the influence function. Here we also use this, and as well as it is used somewhere, some in some other places as well. It is very important concept of linear algebra. By the way, if you know the page rank thing, uh, the Google used uh, here the this eigenvector and eigenvalue thing also is uh, is used. So do you understand the definition of eigenvalue and eigenvector? If you have any questions, please ask me.
I understand.
Good. So we are using eigenvalues to sort this thing and this indirect thing. So to capture this sort of the indirect influence, is to use a measurement called eigenvalue centrality. Okay. So idea is that the person's influence is proportional to the total influence of the people to whom he is connected. So I'm right. The idea is the idea of define the measure is that the person's influence is proportional to the total influence of the people to whom he is connected. Actually, by the way, this is the idea is from the page rank algorithm thing. If you know the page rank thing, have you ever heard about this thing, page rank thing? Page rank. Anybody of you heard about this page rank? If no, whenever you Google anything, so there is a lot of websites are coming in front of you. Have you ever noticed or have you ever observed why some website is on the first stage, the other is on the second, the third? So
Sir,
how
maybe.
Google arrange these things for us?
So I think it's some sort of backend algorithm that would measure the number of page reaches, so that the website or the page which is most popular in terms of reach and everything, that would be on top. Because in some sense it would mean that this page is more related to the person's query than any other page that's on the net.
Yes, you are very right. You are very right. This algorithm, and this is the same thing. This idea is the same thing which we are using for the person's influence. There is the importance of a page. You can say there we the very the page which is more important to the or more relevant to the person's search, and that is what those pages, because whenever there is a page, there are links in of other pages as well. So whenever there is so you can say that a page is more influencer if more uh, web pages have the links of that page. So so this the same idea is for here for the person's influence, and the idea is the same thing, that the person's influence is proportional to the total influence of the people to whom he is connected. जितने भी people जिनके साथ वो connected है उन सब उनका उनका जो influence है उसके साथ उसका persons का जो influence है वो proportional होगा. ठीक है. So let's denote this influence by IE. So let's say, in order to tell you about this function, I'm taking help of an example. Let's say I am a CEO of some company. Because this indirect thing most of the time uh, becomes more influential when there is more influential people. Because when there is a CEO, let's suppose P2 is CEO, and he is connected with the vice presidents, and then vice presidents are connected with different people, so he's more influential person as compared to some lower stage person. So let's say I'm a CEO of a company, and let's name this company X, and there are four VPs. Let's call them VP1, VP2, VP3, and VP4. Okay? So these are the people to whom I'm connected. I'm connected with these people. These are the people to whom I'm connected. When I'm saying connected, I'm saying directly. Okay, maybe indirectly I'm connected with more people. So this measure says, this IE says that there exists some number I call it lambda, let's suppose, and it is not zero, such that the influence of CEO is equals to 1 over lambda times the sum of the influence of the VPs, i.e. of VP1, i.e. of VP2, i.e. of VP3, plus i.e. of VP4. Okay. So here lambda determines how much influence people share with each other through their connections. So if lambda is small, CEO has the lot of influence. And if it is large, then he has a little influence. So everything depends upon this number lambda. Now the question is, how do we calculate lambda? Okay, now we take help of this matrix thing. So we have a graph, this social graph of the connections between the people in a company. And vertices are people, edges are some sort of relation, vertices are people. Some sort of social relationship. Okay, A is the agency matrix of this graph. Of G, and let's suppose there are n people in the company, and they are labeled as, all people are labeled as P1, P2, up to so on Pn. Okay, so यही चीज जो हमने ऊपर लिखी थी, the thing which we have written, so I'll write it again in terms of the every person. So EI of PI, IE of PI is equals to 1 over lambda times the sum of AIJ, IEPJ. Now AIJ are the members of, I write it as small AIJ. J varies from 1 to n. I hope you understand this summation notation. This is for taking a sum of n elements. So if you remember here, AI, when you get AIJ is 1, if PI and PJ belongs to the edge of G, mean they are connected, whatever the relationship we are taking. So if they are connected with each other, you will get 1, and otherwise you will get 0. So in this way you calculate the uh, the 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 influence of the person in the company. Up till now, do you understand this thing? Now I'm going to tell you how this lambda, we can calculate this lambda. Lambda is actually the function of a graph. Lambda is a function of graph. So graph changes, it changes. So not of any individual vertex, yeah, person. So I take all these things in terms of vectors. Okay, so let's suppose these numbers I, E, P, I call them Xi. E of Pi is, I name this number as Xi. Okay, then we can form a vector X whose वेक्टर को मैं बोल्ड से लिख रहा हूँ, I'm writing it as a bold, whose ith component in the influence is the influence of the ith person. Okay, so I write the whole the thing as a vector. So in other words, this vector X is I E of P1, I E of P2, up to so on I E of Pn. So let's compute this. We can write this equation again. If we rewrite this equation, so it will be written as on the left, because IEPIs are equals to these things. Okay. IEPIs are equal to these things. So I can write it like X, the vector X, which is whose components are IEPI and so on. This vector is 1 over lambda times 8, the agency matrix applied on X. Okay, here we have IEPJ. and this thing be equals to lambda x is equals to ax. This is this eigenvalue equation. And there are a lot of algorithm to compute this eigenvalue. So we describe that number, which is the function of the graph, which is the which number, um, uh, if that number is small, then the person's influence becomes more, and if this number is large, the person's influence becomes little. And we say that we get that this number is actually the eigenvalue of, sorry, not the function, eigenvalue of of the matrix A. And A is what? A is the adjacency matrix of the graph. So there are a lot of methods to, if you can have seen from the linear algebra how to calculate the eigenvalue or eigenvector. So and there are some algorithms, lot of algorithms which is used by the softwares to calculate this eigenvalue. So actually the question so in order to calculate the influence, you need to calculate the, the principal eigenvector, because this eigenvector is its components are the are the influence of the different persons in the company. So the calculate someone's influence so according to IE is equivalent to calculating the eigenvector. ठीक है? Clear? If you have any questions, please ask me about this second measure. By the way, this is the same thing which is used for the page rank, the same procedure. There also we need to, in order to find the rank of some web page, you need to find this eigenvalue of the matrix. Okay, do you have any questions? Anything? Any question? Any remark? This is the end of what I want to, of the topic, today's topic. Nobody have any question, any remark, any comment?
So I think it's
You know, the vector x,
Vector x, sorry.
each of the IEP ones, twos, and until ends will have to be calculated by the same process, right?
Yes, by this process, this equation. This equations, this is a standard equation of in linear algebra. If I don't know you people have studied the linear algebra or not, or you have studied eigenvectors or not. So if there are some university students here, so they have there are standard methods to calculate this eigenvalue as well as eigenvector. So if you calculate this eigenvector using the agency matrix, so this vector, the components of this vectors tell you the influence of different persons. Okay, so actually this vector is the components of this vector X is the influence of the individual persons. The ith component is the influence of the measure of the influence of the ith person. Okay, so you have the matrix A, which is agency matrix, and you need to find the eigenvector in order to find the um, in, in order to find the influence of each person. Understand, right?
Yes,
Do I answer your question?
yes.
Okay. Anybody else? Hassamuddin, do you understand?
Yes, sir.
Any question? Any remark?
No, sir. No questions.
Okay. If you have no questions, then thank you very much. Uh, that's it from my side. So the next week, um,